Solve using the elimination method. If there is no solution or an infinite number of solutions, state this. We have the system 2x plus 3y equals 8, 3x plus 2y equals 5. We don't have a pair of opposite coefficients either for the x's or for the y's, so we will need to multiply in order to get those coefficients opposite. I choose to eliminate the y's, though you could just as easily eliminate the x's. We look at the coefficients of y, and you have 3 and 2. A common multiple is 6. So I'm going to make one of these coefficients positive 6 and one of them negative 6. I'll make the top one positive 6. So I need to multiply it by 2, which means I need to multiply everything in that equation by 2. So I have 4x plus 2 times 3y is 6y equals 2 times 8, which is 16. In the second equation, I want to make the coefficient of y negative 6, so I need to multiply everything by negative 3. Negative 3 times 3x is negative 9x. Negative 3 times 2y is negative 6y. And negative 3 times 5 is negative 15. Adding, I have negative 5x plus 0 equals 16 minus 15 is 1. Dividing both sides by negative 5, I get x equals negative 1/5. Now I take this value for x, which is negative 1/5, and now I need to find a y value. I substitute negative 1/5 for x in either of these original equations. I'll use the top one. It gives me 2x, or 2 times negative 1/5, plus 3y equals 8. And I just need to work through carefully. 2 times negative 1/5 is negative 2/5, plus 3y equals 8. And subtract or adding 2/5 to both sides, I have 3y equals 8 plus 2/5. Now I really need to combine those. I need to get 8 in terms of fifths. I think how many fifths would 8 be? Would that be 40/5? 8 times 5. So I have 3y equals 40/5 plus 2/5. 3y would then be 42/5. Now I can divide both sides by 3, but since we're working with fractions, let's go ahead and multiply both sides by 1/3. 1/3 times 3 is 1, so that's y, and 1/3 times 42/5, well, 3 goes into 42 14 times, so I can eliminate or simplify, divide top and bottom by 3, and that gives me 14/5. So I have a possible solution of x equals negative 1/5 and y equals 14/5. Now what we would need to do is to check. We need to substitute negative 1/5 for x and 14/5 for y in both of the original equations. And when we do, we'd find that it makes both of them true. So we can state that the solution is, I'm going to write the solution as an ordered pair with x first. Alphabetical order. Negative 1/5 for x and 14/5 for y.